Hi everyone. In this video we're going to talk about graphing logarithmic functions. So graphing logarithmic functions by themselves might be kind of challenging, but we can use some knowledge that we already have about exponential functions to help us graph logarithmic functions. And that's because we know that logarithmic functions and exponential functions are inverses of each other. And so we also know, or we might not have known this before, but we do now, that the graph of an inverse function is just the graph of the regular function that is reflected about the line y equals x. Okay, and so we have two options here, or they give us two different scenarios. One if a is between 0 and 1, and one if a is greater than 1. And we remember when we started graphing exponential functions that the graph of an exponential function looked a certain way if the base was between 0 and 1, and then it looked differently if it was greater than 1. Okay, and so then we see the two here. The graphs of the exponential functions are in blue, and the graphs of the logarithmic functions are in red. And so you'll see that they're just reflected about the line y equals x. Okay, and so generally, if you look at the red ones, these are how the logarithmic functions are going to work. We almost never deal with logarithms with a base of anything between 0 and 1, so we'll almost never see this left side. We'll always work with the right side. And so that kind of function where I have a graph here, it's going to start at x greater than 0. So remember some important points about a logarithmic function. Its domain is from 0 to infinity, and its range is from negative infinity to infinity. So the graph of a logarithmic function generally looks like this, right? It never goes past the y-axis because the domain is greater than 0, okay? And then it goes quickly to negative infinity, and then slowly, as x increases, y goes to positive infinity. Okay? So that's just some random facts that will be helpful in the future. So let's look at another helpful table about properties of a logarithmic function. We won't deal again with cases where a is less than 1, but even if that's true, they have this here, all that a needs to be is greater than 0 for this table. But anyway, the domain is from 0 to infinity. Okay, we knew that. The range is from negative infinity to infinity. Great, okay. The x-intercept is 1. There's no y-intercept, so generally, for a basic logarithmic function, the graph is going to cross the x-axis here at the point 1, 0. Okay, so that's number 2. The y-axis, x equals 0. This line right here is a vertical asymptote. Okay, so in logarithms we deal with vertical asymptotes, whereas with exponential functions we dealt with horizontal asymptotes. Okay, a logarithmic function is decreasing if a is between 0 and 1, and then increasing if a is greater than 1. Again, usually we're only going to work with cases where a is greater than 1, so we don't really need to worry about that first case. Okay, the graph contains the points blah, blah, and blah. Again, that's just like for exponential functions. And the graph is a smooth and continuous with no corners or gaps. All right, great. So those are properties. Let's use those, again, to graph these functions. But before we do, we need to learn about special logarithmic functions, because I'm going to use two different notations, or two different kind of symbols for logs when we start working with them here in a second. And there's a special kind of log, and that log is one that has a base of e. okay, if I have log base e, it's called the natural logarithmic function, okay, the natural logarithm. So instead of writing log base e, we usually denote the natural log as ln, okay, and that's derived from the Latin logarithmus naturalis. So that's some history there for you, okay, or language. If a logarithmic function has no base, if I write just log, then that is usually taken to be base 10, okay, for us. So log means log base 10. So those are just two things to keep in mind when we work with logarithms in the future. All right, now let's get to graphing logarithmic functions. So we have negative ln of x plus 2. Okay, so again, I'm going to stress two different parts of graphing these functions. Again, this is graphing with transformations. Okay, and so what I'm going to do here is draw them, but for an exam, I would only expect you to write the steps of what happened, okay, of how the transformation changed the function. So we'll start out with the basic, or the base logarithm, which would be the natural log of just x, okay, natural log of x. And if I graphed that, here's a simple xy axis, and it would look something like that. Okay, natural log of x. When I put the negative in front of it, a negative out in front of the natural log is going to flip it over the x-axis. Flip it over the x-axis. And so, what that looks like is something like that, okay, where it's flipped over the x-axis, and we'd say this flips over the x-axis, okay? And then when I add in plus 2, negative natural log of x plus 2, I get, well, if you think about what's happening on the inside, this is very similar, of course, to our exponential sort of partners, so to speak. And so if I'd write e raised to the x plus 2 power, if you remember from last time, when I add or subtract to things attached with the x, attached to x, which is in this case and in this case, that's going to be a horizontal shift, okay? And plus is to the left, negative is to the right, okay? Plus is to the left, minus is to the right. So this is a horizontal shift. To the left 2, okay? And so instead of having the vertical asymptote be at the y-intercept, x equals 0, the vertical asymptote. Now the vertical asymptote is going to be at x equals negative 2. So the graph is going to shift over by 2. It's going to look something like that, okay? And my scales are off, but I think hopefully you get the general picture. Okay, and so for graphing logarithmic functions, it's going to work very similarly to what we saw in the exponential functions. If you put something out in front of the logarithm, that's going to flip it over the x-axis. If you put something in front of the x, that may flip it over the y-axis, but actually, in our case, you can't have a negative inside, so that's going to do something weird. You probably won't see that, okay? But then if you add something inside the parentheses, inside the logarithm, whatever kind of logarithm it is, that's going to be a horizontal shift. And if I'd, for instance, add something outside of the logarithm, that's going to be a vertical shift. Okay, so just keep that in mind when you do your turn. Okay, and so here's the your turn. Graph the logarithmic function log of x minus 4 plus 2. Okay, keep in mind that when I say log, it really means log base 10, although that really doesn't have much to do with how you graph the function. Okay, so keep that in mind. And so when you do this your turn, again, all I want is for you to tell me the steps of how you would graph this with transformations.